Okay, so good morning, everyone. Hello, thanks for joining today to this session. It's about the hour, so I'm going to start. Still more people joining at the moment, but as I said, is about time, so we better go with this session because my time is limited, and I've got a lot of information to share with you today. So let's go to it. First things first, let me move that. Sorry, it's just from my side. I got to move a menu. Right, so we're ready. So again, welcome everybody. Today the session is about creating harnesses for vehicles. This vehicle I'm going to introduce you because this is a real project from a customer in South Africa, MELLOWCABS. So I will introduce this customer to you briefly in a moment. So let's go for it. Okay, first question. We need to go through this one, and I would like to know from you if there is any problem with the sound or the image from your side. Okay, so please, if you can answer this question very quickly. Okay, so the majority of people, 80% of the people have already answered to this question. It looks like a 1% says there is a problem with that. If there is any problem, please type the question through your menu. There is a chat window where you can just type questions. I'm not going to answer the questions during this presentation for respecting the other people in the session to not stop the let's say the flow of the presentation. But I'm going to through all of them by the end of this webinar. Okay, so any problem, just let me know. Type your question in the window chat. Okay, thanks. So let's go. So first thing, again, welcome everybody. Good morning, everybody. Good afternoon, depending on where you are. We got people from several different locations. So today we're going to talk a little bit about creating harnesses inside SOLIDWORKS. And we are going to do that in the context of a vehicle created by the company MELLOWCABS. Okay, these are the different sections today. First thing is I'm going to very briefly introduce you this real project from a real customer, MELLOWCABS. Then I'm going to show you how to place the connectors inside SOLIDWORKS. From the vehicle assembly, I'm going to start placing the connectors in some places, then route the wires between those connectors, and finally get the documentation for production ready, how to do it. And last but not least, questions and answers from your side. Okay, let's go for it. So first, customer story. Okay, so this is MELLOWCABS. MELLOWCABS is a company from South Africa, and at the moment they are creating this vehicle, three wheels vehicle, 100% electrical. Okay, and they started only in South Africa area, but now they are selling everywhere in the planet. Another point for MELLOWCABS to differentiate from the competitors is that they completely customize all the vehicle for the client. Okay, and that was created 100% with SolidWorks tools. They use from, of course, CAD, SolidWorks CAD. They use simulation. They use, you name it, any of the tools we have available in SolidWorks. Very good customer. You can see here that it's the the concept for MELLOWCABS was trying to create a vehicle that was, of course, electrical to be eco-friendly, which is something that we all hear about these days. And they really that was the driver for them, create transportation that was really friendly with the ecosystem, with electrical, but on the top of that, that was very easy to customize to any location or any customer in the planet. If you look for them in Google, you will see many examples around the world of this company of different customizations of the car. Okay, so what we're going to take a look today is how to create a harness, and I mentioned that a moment ago. We're going first for placing the connectors, then define the connections between those connectors, and for that I'm going to use an Excel spreadsheet. Okay, we think that the Excel spreadsheet is a very easy way to customize any information. You just need to put all the information in columns and you're ready to go, and SOLIDWORKS will be able to read that information. Okay, once SOLIDWORKS reads that, routes all the wires inside the vehicle, and then we get the documentation from this routing. So let's start with placing the connectors. Okay. Usually, and I'm talking now to the electrical people on the other side, we are used to not only harnesses, but any electrical design to be very 2D oriented. So we are very used, and I was used back in the day to design anything electrical, even a harness in 2D. Okay, it's really like that. It's really hard 2D stuff, the electrical thing. But there is a genius from an architect, Antonio Gaudí, that designed the Sagrada Familia in Barcelona. That more than 100 years ago, he thought about, wait a second, if I'm creating something in 3D, why I'm drawing that in 2D? And he was really the pioneer to use 3D. Of course, back in the day, it was not digital, was really handmade, but in use 3D 3D prototypes to share that with the people in their projects, to show them exactly how it should look. Okay, it was very complicated to put all this geometry in 2D and explain that to someone else. Okay, so that's kind of the idea behind the SOLIDWORKS Electrical or SOLIDWORKS harness creation. Okay, so let me ask you something before going to the detail of placing the connectors. And my question is this: do you have any issues in production at the moment? Okay. Okay, thanks for answering that. Okay, so yeah, I see that. Yeah, the answer is basically yes. Okay, yes, many times, or sometimes yes. So that's a real scenario. Okay, we try to take the 2D into the 3D space, and this is, believe me, is something very common. I hear from our customers around the world, and is that when you try to get something created in 2D into the 3D space, you get troubles. Okay, eventually. So, okay, thanks very much. Thanks for answering to my survey. Thank you. Okay, and let's continue. Okay, so let's take a look on how to place the connectors in the 3D space. Okay, so here is you will see in a moment. What I'm doing now is just hiding some parts here to be more comfortable with the tool. And what I'm going to do is to insert a connector. Inserting a connector from PDM. The ones that are familiar with SOLIDWORKS tools, PDM is the document management tool for SolidWorks. And yes, that means that you, as electrical, you can have a real management tool for your documents now, even if you're the electrical guy. It's not only for mechanicals. Okay, you can see I'm placing now the connectors in the right position. Okay, and that's very easy with SolidWorks. This is not possible to achieve with a non mechanical tool because electrical doesn't have this ability. Okay, we are working inside SolidWorks with SolidWorks tools completely, and I'm pressing that in the right connection. You can see I can easily navigate from one place to the other. Okay, these views might be created from the mechanical guy, and the mechanical guy just placed the connectors and created some views. For me, I'm the electrical guy, and I just need to navigate from one view to the other, and I will see exactly where I need to add my connector, like I just did now. Okay, so again, if we rotate that and we move to another position and zoom in a little bit, okay, I have more connectors here. So I just need to go again to insert components. All my components are saved in my document management system. I select the corresponding component, in this case, the 6-pin connector, and I place that in the right position again. Okay, very easy. To end this harness demonstration today, I'm going to insert a couple of connectors more. This is a big connector, the one I need now, this one. I'm going to place over this flat surface at this moment. And just to finish, a couple of connectors more. Okay, this one will do. Okay, here we are. So let's insert the 2 last connectors in my vehicle. Okay, SolidWorks allows me to manipulate these connectors manually. Okay, so you can see I can drag those connectors around, and it doesn't matter. I mean, SolidWorks is going to route that anyway. Okay, so it doesn't need to stick to a coordinate or specific position or something like that. No, SolidWorks is going to read the logic I created, point-to-point connections, and is going to connect those connectors regardless of the position they have. Okay, so that allows me to manipulate a connection, not a connection, but a project as complex as it needs to be. It doesn't matter where it's going to be placed, that connector, in which position, SolidWorks is going to route it. Okay. So once we saw this, how to place the connector, now we're going to move to the next one. Okay. Route wires from an Excel spreadsheet, and I'm going to ask you one more thing, and it's how do you calculate the length of your wires today? I put in the question the vehicle, but it could be anything actually. Okay, I choose vehicle because vehicle is really a good example for a very complex way to get the length. And what people does is to take the measuring tape and try to get more or less the length that it should be and make it 20% longer. Okay, so you're safe. Okay, so for what I can see is that for the majority of people, you really use the real prototype. You have the physical prototype there. Okay, you got the physical prototype. Yeah, very interesting. Very interesting. Okay, yeah. So sorry, I'm going. Stop this a second. Okay. Okay, thanks very much. Thank you. Okay, so for the majority of you really use the the real prototype with obviously the cost that this implies. I mean, you really need to have something physical to go there and get it, and probably is not the best way to get the real length, an accurate length. So what I was saying a moment ago about that, well, you go there and you really, what you do is to give like 20% more or 25% more or whatever. It's really what is happening here. So okay, so good stuff. What I'm going now to do is to go to the next step and show you how to take the information, external information from an Excel, and then use that inside SolidWorks. I see that for some reason I got this recorded, but when I put the video, you cannot hear my comments. So what I'm going to do is to play the video locally. Okay, so I guess you will see it. If you have any problem, just please let me know. Okay, I'm going to play it here. Fortunately, I got it in here in my computer. Okay, so here what we can see is that, again, what I'm going to do is no, sorry, this is the previous one. Bear with me a second. Okay, this is the one. Yeah, sorry about that, but okay, here we are. Okay, so, and if you can confirm if now you hear me, that will be great. Okay, so what I'm showing you now is I'm going to I hide some additional parts to leave only the connectors and the clips that I'm going to use later. Okay, and this is a sample of the Excel that I'm going to use today. Okay, the Excel is, the way to understand this Excel is that SolidWorks is going to read that horizontally. Okay, so for instance, if we take the first column, the wire in green, 100 is the name of the wire that I'm going to use in SolidWorks. Then in yellow, you can see J1 and 3. J1 is the connector name that I'm going to connect that wire 100, and the pin number 3, okay, is the pin from that connector. This connector is very big, has many pins, so I'm going to use the number 3 for wire 100. On the other side, also in orange, you can see J21, so the other end of my wire will be J21. And in gray, you can see the manufacturer reference for this specific connector. Okay, so when I create the bill of materials, it's going to show me exactly this information. This Excel is it's a small version of what might be. I could use cables, and I'm not using that today. You can see it's empty. Cable name and cable core, it's empty. I'm not using that. Also, we have the color in that column in black. It's the color that the wire is going to appear. That could grow in many ways, okay? But today I'm going to use those fields only, okay? So now this is the menu where I load my Excel. In the bottom of this menu, you can see that if the name of the Excel is changed, I can change that name just to link the columns in Excel with the database, let's say inside SolidWorks. Okay, once it's linked, I can just accept, and when I load the information, it's asking me to place the components, but the components are already there, the connector, so I'm not going to do it. And here you can see at the left hand side a menu where I got all the connectors from the Excel spreadsheet. In this case, I select the J9 connector, and to link this with any specific connector in my assembly, I just need to select the connector, and that's it. And it will the J9 will disappear from the list, so that allows me to not using the same connector from the Excel twice, maybe. So I have control over this, and I can go for the next one, J9, sorry, 8, and I'm going again to select the corresponding connector. Okay, very easy again. So you can see, once you load the Excel, you are not only taking the connector name and using that in SOLIDWORKS. Once we use the connector and we link that connector with a part here in the assembly, we are also bringing all the information about the connections. We also bring in the wire type, because we know the two ends of the wire. We are bringing the wire type and color, as you saw before, and everything. Okay, so once this relationship is done, I got everything I need for asking SOLIDWORKS to go and route this for me. Start joining pin with pin from this connector to this connector, and it's ready for that. Okay, so now it's finished. I got all the connectors linked with the information from the Excel. I may change the size or whatever, but if I accept, I get these guidelines, these yellow guidelines you can see here. This is a preview of the connections. This is showing me that the connector number 1 connects with the connector number 2 in some other place inside my assembly. Okay, but this is really useful because that is giving me a real information about how the elements are connected without having to go to the 2D documentation, to how the circuits are connected in this, let's say in the 2D space. I got it here. Okay, and taking those guidelines, those preview guidelines, what I can do is to merge them. Okay, because all these guidelines, you can see there are many of them. All these guidelines represent the wires that go from one place to the other place. I can just select them, click on merge is one of the options I have when I select the guidelines, and when I merge them, they get this shape of a branch of a harness. Okay, when I create this harness branch, this is obviously affecting the wires from one end to the other. So I don't, if I do that in one end, that automatically will update on the other end. Okay, I don't need to do that again on the other side, obviously. Okay, so now I got the wires, I got the harness with different branches, but I would like that these branches that go, in the middle of nowhere, they are going through, probably through the geometry of my vehicle. I would like that to take a very specific path, and that's why I added these clips in my car. So I know that if I take the harness through these clips, that will respect the geometry of my vehicle. Okay, you may do it in other ways. I like this one particularly because I think it's very quick and easy. Okay, but there are other ways to do that. Okay, so as you can see, you only need to edit the route, select the segment that you want to make it pass through a specific clip, and then select the clip, and SOLIDWORKS is going to make it real. Okay, in some cases, like here, probably I need to move that around because it's not giving me all the information, or it's probably not the best view for me. The good thing about this route through clip is that you may cancel this anytime, and you may continue later routing this through the clips. Okay, so you see, just cancel that, and we can change the view, move to a view that is more comfortable. Okay, and from that view, I can continue with routing through a clip. In this case, with this different branch. This is very important, this part of the demonstration, because what I'm going to do now, you will see that this branch that goes straight to the end of the other side of the vehicle, what I'm going to do is to pass it through a clip that's already used by another branch. Okay, but that's perfectly right. That means that these two branches are merging in that specific point. Okay, and that has the effect on the harness later. Okay, you may decide to keep those two branches separated all the way through the vehicle. That's fine, but if you need to merge them in let's say in one path, because it's the way that you're going to manufacture this, you may also do it. And you can see SolidWorks is doing that automatically. When you use the same point through a clip twice, he understands that he needs to merge everything. Okay, and that will affect my documentation, as you will see in a moment. Okay. Okay, so let's move to the back of the vehicle and end with the two remaining wires in there. So I'm going to select this one and pass it through the clip again. Okay, so you can see very quick and easy. And the other one. Okay, like this. Then there are more wires back in there that probably a good idea to use a clip for them. And I'm going to again merge all these wires together. But you can see that it's very the concept is that you need to create this Excel to define the point-to-point connections. Once it's loaded, SolidWorks knows exactly how to join these different pins. And the next step will be to edit this path to align with the geometry I'm using in my assembly. Okay, so that's what I'm doing here. Okay, just like this. Exactly, and then these other two that are back in the car. Okay, so we have that. So if you consider this work in 3D, it gives you really a great benefit, meaning that the distance you get, for instance here, if I try to get that from a physical prototype, it's probably very tricky because I don't know if there's going to be space for me, for my fingers to put a measuring tape, or probably for me to put my head inside and look exactly what is the distance. Okay, so I think that the real benefit that we get to use a digital prototype is this, that we get into places that with the physical prototype it's impossible or very difficult. Let's say that it's at least very, very difficult to get. Okay, right, so let's turn some parts on, and you can see that these clips were positioned exactly according to the vehicle. So all the wiring I've created is respecting that geometry in my vehicle. Okay, so I'm sure of that, no problem. You can see that with the transparency. Okay, with the real color, that the color I defined from the Excel, you can see that I have different colors: green, yellow, many of them. Okay, and size, by the way. The section I'm getting here is the real section. You can see that there are different colors here with really small, teeny section, but they merge into big one, into big branch. So, okay, I get all this ready. Okay, very good. And also for that one at the bottom. Okay, excellent. So let's take a look now to the last part of the presentation, which is the generate the documentation. Okay, that's all we've seen about how to manipulate all this information is great, but the target of all this procedure is really to get documentation ready for production, and they will understand without any shadow of a doubt that all the information I'm bringing them, and they won't need to come upstairs to ask me about what means that, etc. Okay. So for that, I would like to ask you if today you're satisfied, and let's think about electrical. Okay, we are talking about electrical stuff today. If you're satisfied with electrical documentation, you can bring today, excuse me, to downstairs, let's say, to the people in maybe in your own place, or maybe externally. If you are manufacturing your harnesses externally, if you don't have any issue, are you satisfied with that or not? Okay, thanks everybody. So almost all the people has answered to that. Okay, thanks for that. So the majority of people said that it could be better. It could be better. Okay, good. So let's take a look to the way that SOLIDWORKS creates this documentation. So you can think about if that's better than the documentation you are using today, or maybe not. Maybe okay, that will be a good point for your questions. Okay, so probably can go over that by the end of this presentation. Okay, so let's take a look to it very quickly about how we are going to create this documentation. We call this the flattening. Okay, we call this the flattening. So let me close the survey. So you should see any minute the MELLOWCABS assembly again, and let's hide some parts. Okay, again, let me make that bigger. Okay, just hiding some parts here. Also the wheels. Okay, here is the harness I created a moment ago, so I'm going to keep that here because the first step will be to flatten this. Flatten means that you take a 3D body, a 3D harness, and you put that in a 2D space. Okay, but respecting the lengths and respecting all the properties in the 3D. We project that in 2D space just to create then the documentation. Okay. So once you flatten, we have the option to flatten clips, and I'm going to select this option because I want the clips to appear in my documentation. Okay. So we select this one and accept. This is a preview of the 3D space, and now you can see my harness projected in 2D, okay, with the clips included. At this moment, at this point, you may change. If you don't like the shape that SOLIDWORKS is proposing for your harness, you may edit that. You can stretch some branches and make it larger, move them around, move the connectors. You can do whatever you need to do, okay? Think about this representation of the harness as non to a scale. There is an option to create that according to a scale. If you choose the option according to a scale, you won't be able to edit the position of that, obviously. But with this one, which is not according to scale, yes, you can do it. Okay, because you will see that we have the distance for each branch, each segment of my harness. Okay. So this is the result, and we can take a look that some tables are created automatically. This table, as you can see here, is a from to list. It looks like the Excel spreadsheet I just imported, okay, previously, but includes the length, okay? Some wires have 0 length. That means that they have not been routed, probably because I'm missing some connectors in my assembly. But the ones that are routed, you get the length for each one. It's a from to list, basically, a pin to pin connection list. Okay, and that's very useful. Well, that's really necessary for anyone trying to manufacture this. You need to start from a connector to the other connector, and you need to understand exactly which pin goes which pin. Here you can see the lengths. I told you about the lengths all around my design. Okay, and some balloons also, and these balloons are linked with the bill of materials. Okay, and the bill of materials is here. We can see the item number is the item number related with the balloon you saw a moment ago. We can see the part number. All that is coming from Excel, if you remember. Okay, a description that also comes from the manufacturer and the quantity. Okay. Okay, so this is the way you get your documentation done. I mean, you just need to go to the flatten option, get the flatten, and once everything is ready, then you just need to select if you want to do it on scale or not on scale and add the corresponding tables. Okay, good. So now I'm going to take a look to your questions, but first there is another question left, and this is coming from our marketing department. So please, if you could answer to this question very quickly, and we go to questions and answers about if you are interested in getting more information about SOLIDWORKS. SOLIDWORKS generally speaking, but also specifically about what we are looking at today. Okay, so thanks for answering this. Okay, thank you. Okay, majority of people have already answered to this. Very good. Thanks. And another one about if you found this webinar effective. Okay, if you feel that it's interesting what you saw, you would like to know more about that, or maybe maybe you are already aware of all this, or maybe it doesn't have any utility for you, whatever. Okay, so that will be very much appreciated if you think that was useful. And as you are answering to this question, I'm taking a look to your questions here. And I will try to, we are running out of time, but I will try to answer as many as I can. Here, some people is asking that is using a non-SOLIDWORKS electrical CAD to do the electrical design. Is there any special consideration using another software which is not SOLIDWORKS? My answer is I would like to, but I cannot tell you anything about other softwares because I would love to know about all the softwares available in the market, but I'm not, unfortunately, so sorry about that. Some other people is asking about if it's possible to include the radius, to a minimum radius available for my wires, and the answer is yes, you can. This option is available, and if you use it, is going to give you an error if it's necessary to you. Fixed length. Is possible to create a wire or a cable with fixed length? Yes, SOLIDWORKS includes that option as well. Okay, so you may define a fixed length for a cable, and it will respect. It's not something that I've used today, but the option it's in SOLIDWORKS for sure. It's possible to get wire list with lengths. Yes, I show you that in my presentation today. You get the table with all that information. Okay. More questions. It's possible to use the option route harness in SOLIDWORKS Electrical 3D to do the same you show us. Yes, it's very similar to that. I prefer to use the more general presentation using SOLIDWORKS tools, but SOLIDWORKS Electrical works very close to that. Actually, SOLIDWORKS Electrical 3D, the engine behind that is the routing in SOLIDWORKS that I use today. Okay. More questions. Yes, I've used a production. Some people is asking about having access to this presentation or training videos and all that. You will get an email from our marketing department, I believe, in the next days. And if you have any requests such as this, access to more documentation, trainings, anything, please answer to that email with your request. Okay, is the best way and easiest way. Okay, more things. A couple of questions more. Someone is asking if it's a separate license. I guess that if it's a separate license, the routing today is included with SOLIDWORKS Premium and SOLIDWORKS Professional at the moment. SOLIDWORKS Premium for sure, and I think Professional too. Okay, so it's not a different license. What you saw today, it's included in your SOLIDWORKS. Again, it's possible to have the presentation recording. Again, you will get the email with all the information about this. More questions? Oh, sorry, it's not in Professional. Thanks, Alex. It's only in Premium, so I thought it was in Professional also. How I created the Excel in the first place. To create the Excel is just typing. I mean, when you create that Excel, you just need to add columns, the information in columns, and just type the information. I'm saying typing because you can use any tool available in Excel. If you, I don't know, if you link that with some external database or you have macros to populate this information, you may use it. I mean, it's pure Excel. The only thing that SOLIDWORKS needs to rivet is that the information needs to be horizontally, okay, in rows to represent any connection, and columns to separate the different types of information we're going to give to SOLIDWORKS. But apart from that, that's all. Someone is asking if I use a 2D diagram to start before using SOLIDWORKS. And in this case, no. I mean, I could create a 2D diagram, send that information to Excel automatically with SOLIDWORKS Electrical, and then import that into SOLIDWORKS. Yeah, I may do that. It's possible. But in this case, if you use SOLIDWORKS Electrical, SOLIDWORKS Electrical has a more friendly way to do that. You don't need to export and import. That's SOLIDWORKS Electrical is doing that for you in the background, so you don't need to manually export and import anything. Okay. Okay. So thanks very much again for your for joining this webinar. A last question before leaving, and again, if please answer if you would like to have any invitation for other webinars by email. Okay, and again, thanks very much for joining this seminar today. Feel free to ask SOLIDWORKS through the email that you will get probably tomorrow, I don't know, about this webinar. Feel free to ask or request any training or anything. But yeah, thanks for answering this question. But probably the best way to get access to any training material or any video or anything will be through your local reseller, SOLIDWORKS. They will be glad to help you on any question you may have. And but yeah, again, you will get that email, so you can answer directly to that email if you feel comfortable with that. Okay. So again, thanks very much, everybody, for joining today. Sorry about the part where I was muted. That won't happen again. Sorry about that. And yeah, I expect you join our next webinar. Thank you very much. Have a good day. Bye-bye.